The, today, I want to talk about section 11.2 series. This is an outline. I want to talk about the definition of a series. What is the definition of convergence and divergence of a series? Third one, what is a geometric series? What is a telescoping sum? The last one, I want to talk about the test for divergence. So first one, what is the series? Add the terms of an infinite sequence an from n equal to 1 to infinity. The a1 plus, a2 plus, a3 plus, you can add it. All entries in a sequence. So we have to use summation notation, summation from n equal to 1 to infinity an, or just a summation of an, which is called infinite series or just a series. How can you calculate an infinite series? So this is an example. 1 over 2 plus, 1 over 4 plus, 1 over 8 plus, 1 over 16 plus, 1 over 32 plus, and so on. How can you calculate? Use the partial sums and the concept of a limit. So what's like a concept of partial sums? The partial sum is like Sn, summation from I equal to 1 to n an. Take limit of Sn. It's like whole idea. Let me see. So we think about partial sum. What's a partial sum? The first one is S1. What's S1? S1 is just the first term, 1 over 2. So like S1. Next, you calculate S2. S2 is, we have two terms. You can have two terms, 1 over 2 plus 1 over 4. The 1 over 4 plus 1 over 2 is like change. 1 over 2 is 2 over 4 plus the 1 over 4. Answer is 3 over 4. The next one, partial sum S3. What's like S3? You add 3 terms. The 1 over 2 plus 1 over 4 plus 1 over 8. Here, 1 over 2 plus 1 over 4 is the previous result, exactly 3 over 4. Plus 1 over 8. You can find common denominator 4 and 8. The 3 over 4 is the same to 6 over 8 plus 1 over 8. Answer is 7 over 8. 7 over 8, this is a 3. So keep going. You can guess. What is S4? S4 is 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16. So what do you think? What is the answer? S4. Could you run your answer on the chatting board? What's S4? Yeah, 15 over 16 is right. The 15 over 16. So let me see. You think about it. So what's like the difference between this top one and the bottom one? Top one is 1 and 2, difference is 1. The 3, 4, difference is 1. 7, 8, difference is 1. You can keep going, same procedure. Yes, we have 15 over 8. You can change it to this one, the next one. This is what? 2 to the power 1 minus 1 over 2 to the power 1. This one is 2 square minus 1 over 2 square. 7 over 8 is 2 cube. 2 cube minus 1 over 2 cube. And 15 is 2 to the power 4 minus 1 over 2 to the power 4. So keep going this procedure. What is like Sn? The Sn is exactly summation I equal to 1 to n, 1 over 2 to the power I, exactly 1 over 2 plus 1 over 4 plus 1 over 6, 8 plus, keep going. Last one is 1 over 2 to the n. What's that? So we have this rule, 2 to the n minus 1 over 2 to the power n. You can find some trend, right? Like this. So this is like a partial sum. What is like a series? You add infinity many terms. What does it mean? You can take limit. So here, you can take limit. Sn is given. Sn is summation I equal to 1 to n 1 over 2i. Exactly. This one is given. You can add more. So what does it mean? Take limit 2 to the n minus 1 over 2 to the n. You can take limit. N approaches infinity. Take limit. N approaches infinity. Take limit. N approaches infinity. What is the answer? What's the limit of 2 to the n minus 1 over 2 to the n? What is the answer? Could you run your answer on the chatting board? What is the answer of this question? What's that? What is the answer of this one? What is the answer of this one? The infinity of infinity, you're right. The infinity of infinity. Do you remember the previous section 6.8? You just find the solution by using L'Hopital's rule, or in this case, relative ratio graph. You have to ignore lower term. The lower term minus 1 we can use like this. 2 to n is crossed out, answer is 1. So we have 1. So what's the final answer? The final answer is 1. That's it. This is the idea. How can you solve this problem? You just only use partial sum and take limit. This is the whole idea for solving this problem. Like this. So how can you check it? General series has a sum or not? So we consider partial sum and the conceivable limit from the previous example. The S1 is like only one term A1. You can use the sequence and series is different. What is sequence? Sequence is only list of numbers. This one. What is like a sequence? The sequence is only list of number. The previous example is like 1 over 2, 1 over 4, 1 over 8, 1 over 16. The AN is 1 over 2 to the n, like this. Only list of number. What's like a series? The series is summation. Only summation. It's good? It's like a difference between the sequence and series. So how can you check? The sequence is convergent or the divergent? How can you check? The sequence is given. In this case, take limit of an. N is going to infinity. 1 over 2 to the n is going to what? 0. So we call like this. The sequence is convergent to 0. What's like a series? From the previous calculation, this is like 1. How can you say? Series is convergent to 1. It's totally different. The sequence is list of numbers. The series is summation of numbers. Okay. So here, S1 equals A1. The summation from I equal to 1 to 1 AI. You can use summation notation. S2 is A1 plus A2. Summation from I equal to 1 to 2 AI. S3 is A1 plus A2 plus A3. You can use summation notation. Summation I equal 1 to 3, right? Starting index is 1. The terminal index is 3. S4, similar. A1 plus A2 plus A3 plus A4. Summation I equal to 1 to 4 AI. What's SN? So A1 plus A2 plus till AN. You can use summation notation. I equal to 1 to n AI. So next, evaluate limit of Sn. What does it mean? the limit of Sn is exactly series, summation of infinity many terms, like take limit. This is the whole idea for solving series problem. What's that? Partial sum and limit. Partial sum and limit. So like this. The series converges if the limit exists. The series diverges if the limit does not exist. Right? We are going back to previous example. The previous example is conversion or diversion. What do you think? The previous example, 1 over 2 plus, 1 over 4 plus, 1 over 8 plus, keep going on. What is the answer? The previous example is conversion or diversion. Answer is converges. Is it right? Yes. So thank you for answering my question. Thank you. Here, what happened to the previous one? Previous one is, what's that? The limit of Sn is 1. So we call the series. This series converges, we call converges to 1. This is the answer of this question, like this. So this one, like this. Let me see. I'm going to summarize the previous result. The A1, A2, A3, you can add it, all terms from 1 to n, that we call partial sum, summation I equal to 1 to n AI. So we can use notation Sn. Sn is like partial sum, right? The partial sum. You can use summation notation, like this. What's it like whole thing? So you can add infinity many terms, only take limit. This is the same to limit and approach infinity, summation from I equal to 1 to n AI, the limit of Sn, the limit of a partial sum. This is like a whole idea. The summation an is conversion. What does it mean? The limit exists. The summation of an is diversion. The limit does not exist. What does it mean? It does not exist. Answer is infinity, the negative infinity, or oscillating, like this. In this case, the divergent. So we think about one special series we call geometric series. The geometric series is like this one: a plus ar plus ar squared plus ar cubed plus ar to the n minus 1 and keep going. That we call geometric series. Was it like a summation form? The summation from n equal to 1 to infinity, a times r to the n minus 1. The a is not equal to 0, this assumption. So what's the partial sum here? A plus ar squared, keep going, the nth term. This is like, what's that? This is first term. This is second term. This is third term. This is the nth term. You can only add till nth term. So case 1, I'm going to check the geometric series is convergent or divergent. First case, r equals to 1. So what happens? R equals to 1. What's that? What's Sn? Sn is like this. So because you plug 1 into here. So a plus a times 1 is a times 1 squared is a times 1 to the n minus 1 is also a. Yeah. A plus. How many a's do we have? We have how many a's? The n a's. The n a's. What is the answer? So this is n times a. Does it make sense? One example is 2 plus 2 plus 2 plus 2. How many 2's? 4. So we have 4 times 2. You can write like this. So this is n times a. So na. So next one. Take limit. The limit of here, exactly the limit of n approaches infinity n times a. So what's the answer? We have 2 possible answers depending on a. A is a positive number. So what does it mean? The one example is limit. The n approaches infinity. the n times just 2. N is going to infinity. Infinity times 2 is positive infinity. So we have it. Second one, the a is less than 0. What's that? The one example is limit n approaching infinity, the n times negative 2. N is going to positive infinity. Infinity times minus 2 is negative infinity. So we have negative infinity. Yes, we have a positive one, negative infinity. So we have these kind of answers. So like this, always divergent, always divergent. R equals 1, divergent. Second case, R equals minus 1. So what happens? So what do you think? You can plug the minus 1 into here. What's that? So Sn is, what's that? First one is A plus. The minus 1 times A is negative A. Third one is A plus negative A. So keep going. The last one is plug minus 1 into R. So we have minus 1 to power n minus 1 times A. So what is limit of Sn? What's the limit? So could you write your answer on the chatting board? So what happens? What's the limit of Sn? So could you write your answer on the chatting board? What is your answer? Diverges. That's right. Diverges. So A was 0. A was 0. Yep, you're right. What is S1? S1 is A. What is S2? S2 is A plus minus A is A. Sorry, 0. What is S3? S3 is A plus negative A plus A. A is cancelled A. What is S4? So keep going. So we have 0. S5 A. What's that? A 0 A 0 A. Yes, this is what? Oscillating. Oscillating. The limit does not exist. So what's that? Divergent. Divergent. So like this. Yeah, this explanation. So does not exist. Diverges. The third case. The third case is R is not equal to 1, R is not equal to minus 1. How can we solve? We think about partial sum, this one. The next, so we think about R times Sn. What's like R times Sn? Here. So R times Sn is, so here. So what's that? This one times R, is right? This one times like R. So we have the R times A is A times R. Plus R times AR is AR squared plus AR cubed and keep going. The A times R to the n minus 2 times R is A times R to the n minus 1 plus R to the n minus 1 times R is the A times R to the n. So what happens? We have this result. Here. What is R times Sn? Keep going. AR plus AR square plus AR cube plus keep going. A times R to the n minus 1 plus A times R to the n. Next, subtract. What happens? Sn minus R times Sn is. So what happens? So A, you have to keep. This one, AR minus AR, cancelled. AR squared minus AR squared, cancelled. Here, AR cube minus AR cube, cancelled. Keep going. This one minus this one, cancelled. The previous one also cancelled. All things cancelled. So what's the remaining things? The negative a r to the n. Negative a r to the n. The next, so you just need to factor out Sn. What's it like Sn? 1 minus r times Sn equals, same, factor out a. A times 1 minus r to the n over, that's it. Next one, divide the both sides by 1 minus r. So here, I can erase this one. You can divide the both sides by 1 minus r. 1 minus r crossed out, what's like Sn? So Sn equals a times 1 minus r to the n over 1 minus r, so like this, right? So we have it. This is idea. So like this. Next, you can take limit. Take what? Limit. Limit of Sn here. Limit n approach infinity, the Sn. So we have limit n approach infinity, Sn is a times 1 minus r to the n over 1 minus r. So we have this kind of things. So what is answer? So what is answer? Depending on r to the n. R to the n approaches some number, whole thing is approaches to some number. R to the n is divergent, whole thing is divergent, depending on r to the n. So how can you check r to the n is convergent or divergent? We think about only these cases. R is not equal to 1, r is not equal to minus 1. So we can draw real line except to minus 1, except to 1. You can choose point, one example, negative 2. What happens? Negative 2 to the n. Take limit of r to the n. The limit of r to the n is limit of negative 2 to the n, and is going to infinity. What is the answer? What's that? Yeah, diverges. Is it right? Diverges. Yes, diverges. What's it like a negative 2 to the n? You can plug 1, negative 2. You plug 2, 4. Negative 8, 16. What's that? Oscillating. Oscillating infinity many times. Limit does not exist, so divergent. What happens? You choose some point between minus 1 and 1. One example is negative 1/2. You can choose minus 1/2. What's the limit? N approaching infinity, the minus 1 over 2 to minus 1 over 2 to the power n. What's that? What is your answer? The limit minus 1 over 2 to the n. What's your answer? Could you run your answer on the chatting board? What is limit of minus 1 over 2 to the n as n approaching infinity? The answer is, what do you think? The zero? Is it right? Is it right, zero? Is zero? Yes. You plug n equal to 1. The first term is negative 1 over 2. Second term, minus 1 over 2 squared is 1 over 4. The third term, negative 1 over 8. What happens? Length is decreasing, going to 0. So going to 0. So what happens? You can choose any point between minus 1 and 1, always going to 0. You can choose any number greater than 1. One example is like 2, and calculate limit. N approaching infinity, r to the n, the 2 to the n. What happens? The plug 1, 2. Plug 2 into n, 2 squared equals 4. The 8, 16, 32, 64. Going to what? Infinity, always divergent. So we have two possible answers. So if r is between minus 1 and 1, between minus 1 and 1, what happens? R to the n is going to 0. Remaining part is a over 1 minus r. The next one, the remaining part. The r is less than minus 1 or r is greater than 1. What is the answer? Always divergent. The divergent. So you can combine case 1 case 2, case 3. Was it like a case 1? Case 1 is R equals 1. What is the answer? Divergent. So R equals -1. What is the answer? Divergent. You can combine case 1, case 2, case 3. Case 3. So we have this result. So we have this one. The geometric series is this one. Is conversion to the if absolute value of is less than 1. What does it mean? So this one is exactly same to what? So R is between -1 and 1, so exactly same. And sum is A over 1 minus R. This is like the summation, A over 1 minus R. The R is the absolute value of R is greater than Y equal to 1. What does it mean? So this part is exactly same to the R is less than Y equal to -1 or R is greater than Y equal to 1. In this case, series is divergent. So we have a name. A is first term. The R is common ratio. The common ratio. Is right? So this is like whole idea. So why do you call R be common ratio? Why do you call R common ratio? Because you can think about the first term is A1, second term is A2, third term is A3, first term is A4. We can think about ratio. What is A2 over A1? A2 is AR over A1 is A. A is crossed out the R. What is A3 over A2? A3 is AR squared. Over A2 is here, AR. A is crossed out, R is crossed out, just to R. What does it mean? Ratio is same. So we call common ratio. A common ratio. It's like a geometric series. So you need to know this one. The absolute value of R is less than 1. We have convergent result. The absolute value of R is greater than Y equal to 1. Series is always divergent. We have two results from the geometric series. Can you memorize this one? The next tip. Find the sum of geometric series. I'm gonna check. This is like a geometric series 1 now. This is geometric series. How can you know that? Here. 5 is given. How can you find negative 10 over 3 from 5? Exactly. Plus 5 times. What number do you need? Negative 2/3. 2/3 times 5 is this one. Plus, how can you find 20 over 9 from negative 10 over 3? Same. So times negative 2 over 3. So we have the second term times negative 2/3. The first term, the second term times one more square. So this one is plus 5 times. What's that? How can you find the first term from the third one? Same. Times negative 2/3 again. So we have 5 times negative 2 over 3 cubed. And so on. So this is exactly geometric series. So you can check. The geometric series is convergent or divergent. What do you think? Convergent or divergent? What is your answer? Convergent? Is it right? Convergent? 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 Okay, convergent, convergent. Okay, good. Convergent. Okay, good. So, what is common ratio? What's a common ratio? So in this case, you need to find what is A, what is common ratio. You can find this kind of things. Was it like A? Yeah, common ratio is negative 2/3 here. Negative 2/3 is common ratio. This row is common ratio. A is, yes, 5. The first term 5 is A. The common ratio is negative 2/3. I want to check the series is convergent or divergent depending on common ratio. We can take absolute value. Absolute value of negative 2/3 is only 2/3. 2/3 is less than 1. From the previous result, yes, we have convergent result. What is answer? Answer is always A over 1 minus R. So A is 5. 1 minus negative 2/3. 5 over 1 plus 2/3. 5 over 1 plus 2/3 is 5/3. The next is 5 times the reciprocal of denominator, 3 over 5. 5 is crossed out, answer is 3. So that's it. This is the whole idea for solving this problem, right? Like this. This one. So what's the key? You can find the common ratio, you can check. The absolute value of R is less than 1, yes, convergent result. Absolute value of R is greater than or equal to 1, always divergent. Always divergent. This is like whole idea for solving this problem. So next tip. Here. So what do you think? So this is geometric series. The geometric series. So what do you think? This is like a geometric series. Summation from n equal to 1 to infinity, 2 to the 2n, 3 to the 1 minus n. So, okay, good. So how can you find common ratio? What is the common ratio of this problem? Do you know the common ratio? So if you want to check this is convergent or divergent, always find common ratio. Common ratio is 4 over 3. Is it right? 4 over 3? So what do you think, other students? So could you write your answer on the chatting board, please? So what do you think? What is the common ratio? How can you find? This is idea. So you can change this one to this form. Summation n equal to 1 to infinity. First one, this is not good. I'm gonna split. 2 to the 2n times 3 to the 1 times 3 to the minus n. So like this. One more, summation n equal to 1 to infinity. The power 2 is not good. Change to the only n. How can you do that? 2 squared to the power n form. Times 3. One more. The negative power, you can change it to the positive power. 1 over 3 to the n. So same to summation. N equal to 1 to infinity, 4 to the n times 3 times 1 over 3n. This is summation from n equal to 1 to infinity. Only the interchange order. So 3 is like front. You can combine 3 to the n, 1 over 3 to the n. You can combine this one. So 4 to the n times 1 over 3 to the n. What's that? We have 4 over 3 to the n. You can combine like this, right? Because it's same to what? 4 to the n over 3 to the n. It's the reason. Only take out n. So we have 4 over 3 to the n. So like this. 4 over 3 to the n. So what is common ratio R? Common ratio R is this one, the inside one, the base of exponent, the base of exponential form. So why? You can plug n equal to 1 to here, same to 3 times 4 over 3. Second term, plug 2, 3 times 4 over 3 square, plus 3 times 4 over 3 cube, and so on. So what's that? The 4 over 3 is exactly common ratio. Next, take absolute value. Absolute value of R is absolute value of 4 over 3. Absolute value of 4 over 3 is 4 over 3. The 4 over 3 is the greater than what? Equal to 1. What is the answer? Answer is series is divergent. Series is divergent. So that's it. This is the whole idea for solving this problem. So like this. That's good. The next one. Write the number 1.24. Was it like the upper 4? The 4 is repeated. 1.2, 4, 4, 4, 4, 4, and so on. You can change it to the ratio of integer. How can you change the ratio of integer? We can use geometric series. So what does it mean? So this one is same to what? So like this, right? The 1.2 plus 0.04. The second 4 is 0.004. The third 4 is 0.0004, and so on. Keep going. So how can you find geometric series? 1.2, 0.04, we don't have any relation. We don't have any relation. So you have to ignore 1.2. What does it mean? Only keep 1.2 separately. So here, 0.04 plus. How can you find 0.004 from the previous term? What's that? 0.04 times 0.1, exactly 0.004. So we have 0.04 times 0.1 plus here. What's that? Same. Second one times 0.1 again, 0.0004. So we have 0.04 times 0.1 is exactly previous one times 0.1 again, exactly square. And next one is 0.04 times 0.1 cube, and so on, like this, right? So you have to split 1.2 and remaining terms. This remaining term is geometric series or not. The remaining thing is geometric series. What do you think? 0.04 plus 0.004 times 0.1 is right? The geometric series. Okay. So you need to find common ratio R. What's the common ratio R from here to here? So exclude 1.5. What's the common ratio? Yes, 0.1. 0.1 is exactly common ratio. What is A? So exclude 1.2 from 0.004, like this one. Was it like A? Not 1.2. So because we don't have any relation. We don't have any relation of this one. You have to exclude 1.2. So 0.04, 0.04. 0.04 is A. So what's that? You have to keep 1.2 plus the starting number is 0.04 is A. We have A over 1 minus R, is right? Because the absolute value of R is absolute value 0.1. It's like 0.1 is less than 1. Always less than 1. So like we have a conversion result. So we have 1.2 plus what is A? 0.04 minus 1 minus 0.1. We have 1.2 plus. This is 0.04 over 0.9. So what's that? You can change it to what? Ratio of integers. You can change integer. How can you do that? The top one and bottom one by 100. You multiply 100. So what's like 1.2? 1.2 is same to 12 over 10 plus. The 100 times 0.04 is just 4. 0.9 times 100 is 90. So what's that? You have to simplify more. This is same to the 12 over 10 is same to what? The only cross out 2, we have 605 plus the 2 is crossed out 245. the 2 over 45. The next, so you can find common denominator, 5 and the 45. The 45 is a common denominator, only multiply top and bottom by 9. 6 times 9 is 54 over 45 plus 2 over 45. So we have 56 over 45. That's it. This is the final answer for solving this problem. So like this. The next one. Show that the series summation n equal to 1 to infinity 1 over n times n plus 1 is a conversion and find its sum. So how can you solve this problem? How can you solve this problem? So what do you think? So you can use this idea. So in this case, so you have to borrow the one idea from partial fraction, section 7.4, the partial fraction. So what does it mean? You have to split this one first. Here, you can split 1 over n times n plus 1. You can split the a over n plus b over n plus 1. You can change some of the two fractions, like partial fractions. You can combine again. A times n plus 1 is a times n plus 1 plus the b times n over n times n plus 1. Same to the an plus bn is right. The an plus a plus bn over n times n plus 1. So an plus bn is factor out n, a plus b times n plus a over n times n plus 1. So we have this one. The next is, you can compare. You can compare this one, 1n, the remaining part, the numerator, a plus bn plus a. You can compare these two things. What is a plus b? So could you write your answer on the chatting board? What is a plus b? You can compare. This is blue one. 1n, a plus b times n plus a. What is a plus b? So could you write your answer on the chatting board, please? What is a plus b? A plus b is 1. So my point is here. What's that? This is 1 equals the a plus b times n plus the a. So let me see. What's that? The same to what? 0 times n plus 1 form. So 0 is a plus b. Remember this one? N is like a variable. A plus b is like a 0. What is a? What is a? A is, what is a? Yup, is what? Is constant 1. You can plug 1 into first equation, same to 1 plus b equals 0. You can subtract 1 from both sides. B is minus 1. A equals 1, b equals minus 1. Right? We have this one. So what's that? You can plug. A is 1, B is negative 1. So you can replace. This one is going to inside one. What's that? So we have this one. Summation n equal to 1 to infinity. 1 over n times n plus 1 is summation. N equal to 1 to infinity, the split form 1 over n here. 1 over n minus 1 over n plus 1. So like this. The next thing, so you have to use definition. What's like a definition? Change it to the limit and partial sum. This is same to what? Limit. N approaches infinity. Summation from I equal to 1 to n. You can replace n by I. So we have 1 over I minus 1 over I plus 1. So next thing, you can keep limit n approaches infinity. So you can calculate partial sum first. I'm going to use expanded form. What's it like the first term? I equals 1. You plug 1 into I. The first term is 1 over 1 minus 1 over 1 plus 1 is 2. Next is second term. I equals 2. You plug 2 into I plus the second term plug 2 into I. 1 over 2 minus 1/3 plus the third term plug 3 into I. 1 over 3 minus 1 over 4. Keep going. So was it like last term? The last term is plug n into I. So we have 1 over n minus 1 over n plus 1. What is previous one? Previous one is, the was it like a previous one from the n minus 1 is previous one. You plug into I. So we have 1 over n minus 1 minus 1 over. The n minus 1 plus 1 is just n. So this form, what happens? You keep limit. N approaches positive infinity. So what happens? 1 over 2 is cancelled. 1/3 is cancelled. 1 over 4 cancelled from the previous one. This one is cancelled from previous one. So 1 over n is cancelled. We have remaining terms 1 over 1 minus 1 over n plus 1. So we have 1 over 1 minus 1 over n plus 1. So what's that? The limit of constant is just 1. You can calculate second part. You plug infinity into n. 1 over infinity is just 0. That's it. What's the answer? So we have 1. So that's it. Answer is what? So this one is called infinity. 1 over n times n plus 1 is, yes, just 1. This is the final answer of this question. So in this case, it's not a geometric series, so we can use the previous result from geometric series. So this is the only idea. This is only idea for solving this problem. This is like the best way to only use like partial sum, right? So do you remember this one? So how can you solve integral 1 over x times x plus 1 dx? Do you remember? How can you solve this one? So we can use partial fractions, right? 1 over x times x plus 1 is a over x plus b over x plus 1. So we can use cross multiplication, find a and b. We can plug here, change integral 1 over x minus 1 over x plus 1 dx. Next, find individual integral. You can use only partial sum, so like this, very similar idea. The always change partial sum. This one to the partial sum. The next key part is you can expand partial summation always crossed out. This is like one good way. This is like this is the reason. This is the reason. Then we use the partial sum because you have to cancel the like middle terms. So cancel all middle terms. We have only one simple one, only take limit, that's it. This is the whole idea. Yeah, this is like, so Yeah, we will use this method. We don't have any method. The one more. So you don't want to find this kind of things. One idea is use a formula is another possibility. What kind of formula? The next one. 1 of n plus a times n plus b form. How can you change this one? Always 1 over b minus a. Just use the formula. The 1 over the n plus a minus 1 over n plus b. So that's it. Use a formula. This is like another idea. So what does it mean? So this form is given. This form is given. You can compare 1 over the n times n plus 1 is given. So you can find a and b. What is a? What is b? In this case, n plus 0. The a is 0. n plus 1 is b equal to 1. So the one more. In this case, the b is greater than a. Just like one key part. So you can use it. 1 over b minus a. 1 minus 0. The 1 over n minus 1 over n plus 1. Just use formula. Exactly. The 1 over n minus 1 over n plus 1. So that's it. We can use a partial fraction, right? This is like another method for solving this problem. Anyway, the main key for solving this kind of problem, 1 over n times n plus a, n plus b form. We have inside the one has this kind of forms, always change it to partial sum. This is like a way for solving these problems. Okay. The next one. So we are going to next problem. The next problem is this one. To show that the series convergent divergent, I'm going to explain this kind of things. This is the same to my previous example. So we have a name of this one. We call telescoping sum. So we call telescoping sum. This is like a name of this one. The next example here, we think about harmonic series. The harmonic series is convergent or divergent. Convergent or divergent. So we think about this one. The S2, 1 plus 1 over 2. We think about S4. S4 is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So like this. So one more. You can compare 1/3 by 1 over 4. Which one is bigger? The 1/3 is bigger. So we have like this. You can keep everything plus. Only replace 1/3 by 1 over 4. This is 1 plus 1 over 2 plus 1 over 4 plus 1 over 4 is 1 over 2. I can change it. 1 plus 2 over 2. So like this. You can change it like this. The next S8. S8 is add first 8 terms. 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5, 1 over 6, 1 over 7, 1 over 8. You have two grouping like this. So similar. Only replace 1/3 by 1 over 4. So here, so we have only this inequality here. 1 plus 1 over 2 plus. So replace 1/3 by 1 over 4. 1/3 is greater. So 1 over 4 plus 1 over 4. The remaining terms only compare with 1 over 8, 1 over 8, 1 over 8. 1 over 5 is greater than 1 over 8. 1 over 6 is greater than 1 over 8. 1 over 7 is greater than 1 over 8. So we have plus 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8. So what happens? 1 plus 1 over 2. The 1 over 4 plus 1 over 4 is 1 over 2. 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8 is 4 over 8. We have 1 over 2 again. You can combine the 3 1 over 2's, 1 plus 3 over 2. So we have this result, like this. So what happens right now? The first one, we have this result. Was it like S2? S2 is exactly the same. It doesn't matter. Greater than or equal this one. 1 plus 1 over 2 form. Was it like S4? We can change it like this. S2 squared is greater than or equal 1 plus 2 over 2. So let me see. Third one, S8 is 2 cubed. Is it greater than or equal here? The greater than or equal 1 plus 3 over 2. So we can keep going this procedure. What happens? S to the 2 to the 4, S16. What's that? 1 plus 4 over 2. And keep going. What is S to the 2n? Equal to what? 1 plus n over 2. Is that right? So like this. So we have it. Next, take limit. N approaches infinity. S to the 2 to the n is greater than or equal limit. N approaches infinity. The 1 plus n over 2. What is the answer of this one? What's the limit? N is going to infinity. 1 plus n over 2. What is the answer? Answer is divergent. Is right? Divergent? Yes. Was it like a special number? This n is going to positive infinity. The infinity over 2 is, yes, infinity. 1 plus infinity is infinity. So, limit of S2n is greater than or equal to infinity. What is the answer? We have only one possibility. Limit n approaching infinity. The partial one, S to 2 to the n is going to what? Just infinity. So we have it. So from here, we can think about general one. N is approaching infinity, general term Sn. The 2 to the n is going to infinity, S is going to infinity. N is going to infinity, S is going to, yes, infinity, infinity. So what's your final answer? Always divergent. Answer is infinity. That's it. It's like a proof of this kind of things. So we have one good result. What happens? Harmonic series, 1 plus, 1 over 2 plus, 1 over 3 plus, 1 over 4 plus, and so on. This harmonic series is always going to positive infinity, always divergent, always divergent. So this is one good result. You have to keep in your mind of this result. So like this. Here, harmonic series like divergent. The 16, the weird one theorem. Theorem 1. So if the series is convergent, then limit of an is going to 0. The series is convergent, the limit of n is always going to what? 0. Always going to 0. Always going to the 0. It's like true. Proof. You can think about Sn. The A1 plus, A2 plus, A3 plus, keep going. The A sub 2n minus 1 plus an, like a partial sum. We think about an minus 1. An minus 1 is you only add n minus first terms, till n minus first terms, a1 plus, a2 plus, a3 plus, till an minus 1. The next till, subtract. What's that? Sn minus S sub 10 minus 1 is a1 minus a1 cancelled, a2 minus a2 cancelled, a3 minus a3 cancelled. Remaining thing is all cancelled. What's the remaining things? Only an. So we have it. Sn minus 1 equals an. So we have it. So like this. So we change it. So this one is like this. So we have it. So exactly, limit of Sn is S because the summation n equal to 1 to infinity, an is conversion from this result. From the result, this is true. We have a finite number. The next n is approaching infinity. What happens? n minus 1 is also going to infinity. So Sn minus 1 is also going to S. Does it make sense? The one example is like this. So what do you think? Sn is 1 over n. What's the limit of Sn? What's that? Limit of Sn. N is going to infinity. The 1 over n is, what is your answer? Yup. 0. You're right. We think about Sn minus 1. Sn minus 1 is, you can replace n by n minus 1. So like this. You think about limit n approaching infinity, Sn minus 1. It's a limit. N approaches positive infinity. What's that? 1 over n minus 1. What is the answer? 0. Always same number. The limit value doesn't change. Is right? Limit of Sn is going to S. Sn minus 1 is also going to S. It doesn't matter. So, like this. We have it. Always have it. Same things. It's like a key. The next thing, we can check this conclusion is true or not. We can use this result here. An is Sn minus Sn minus 1. We can take a limit of both sides. Limit n approaches infinity. Take a limit n approaches infinity. Like this. You can distribute limit. The limit of Sn, the n approaches infinity, minus limit of Sn minus 1 as n approaches infinity. What's that? The first one from the assumption, S. Second one, also S. S minus S is 0. Do we have this conclusion? What's the conclusion? Limit of an. Limit of an, n is going to positive infinity equal to 0. That's it. This is true. This is true. Right? So this is true. One more. So from here, I'm going to give one example. So one example, you can assume that summation n equals 1 to infinity, an equals 1000. The question is find limit n approaches infinity, the cosine of an. So this is the equation. So what's your answer? So could you run your answer on the chatting board? What is your answer? So we have the one assumption. Summation from n equal to 1 to infinity an equals 1000. Find limit of cosine of an as n approaches infinity. What is your answer? Does it not exist? Does it not exist? Is it right? Does it not exist? So what do you think? The other students. Is one? Is one? Is one? What do you think? One does not exist. Other answers? One? Is one? Cosine 1000? What do you think? Yeah. Could you write your answer on the chatting board? It's a good part. Cosine 0 is 1. So let me see. So here, just same to what? Limit is going to inside 1. So what does it mean? So we have cosine of limit n approaches infinity an. What is limit of n? You can use theorem. Series conversion here. Series what? 1000. Series like a conversion. What's the limit of an? Always 0. always 0. So we have cosine of 0. Cosine of 0 is 1. So that's it. This is the whole idea by using theorem. By using theorem. It's always true, like this. The next one. If limit n approach infinity an equal to 0, then summation from n equal to 1 to infinity an converges. This statement is true or false? True or false? What is your answer? You can choose one out of 2 answers. True or false? What is your answer? Could you write your answer on the chatting board, please? So what is your answer? True or false? True? Is it true? True? So true? True? Is it true? You think about this one. Summation n equal to 1 to, yeah, the students said like first, the other students like true. Because of 1 over n, yeah, this reason. Summation n equal to 1 to infinity, 1 over n. So this is convergent or divergent. From the previous result, harmonic series is always going to infinity like divergent. But what is the limit of an? Limit of an is limit of n approaching infinity, an is 1 over n, going to what? 0. 0. So what is the answer? First, this is example. Divergent, but limit is going to 0. So this is not always true. Always true. So first, this is counting example, like this. The harmonic series. This is like one good example. So you can use contraposition, like logic things. We have this result. Test for divergence. The limit of an does not exist, or the limit of an is not equal to 0. So what is the answer? Series is divergent. Divergent, right? So what does it mean? So one example is like this. So we have an assumption. Limit n is going to infinity an. Sequence is going to 5. The question is find. What is your answer? The limit of an equal to 5. You can define summation of an. So what is your answer? So what is your answer? Summation of an? What's that? What's your answer? So could you run your answer on the chatting board? The limit of an equal to 5, what happens? This one. So change a little bit. So this is not good. You can check. If the series is convergent or divergent. Change it like this. What do you think? So sequence is going to 5. What happens to series? Convergent or divergent? Could you write your answer on the chatting board, please? Divergent? 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 Yep, you're right. So because here, limit of an is not equal to 0. 5 is not equal to 0. What's the conclusion? Series is always divergent. We call test for divergence. So answer is yes, divergent. This is the whole idea. So this is example. I'm going to show this is divergent by using this one. So we have an. This is an. This is an. You can calculate limit n approach infinity an. Limit n approach infinity an is 2n squared plus 5 over 3n squared plus 2n plus 1. So this is infinity over infinity. I want to use relative ratio growth. You have to ignore lower terms. The limit n approaches positive infinity, 2n squared over 3n squared. So what happens? N squared is crossed out, answer is 2/3. The limit of an is 2/3. 2/3 is non-zero. 2/3 is non-zero. What does it mean? We can use the test for divergence. What's the conclusion? Summation is always divergent. You can write like this. Summation n equal 1 to infinity 2n squared plus 5 over 3n squared plus 2n plus 1 is diverges. Diverges by using the test for divergence. Test for divergence. That's it. That's the whole idea for solving this problem. Here, like this. So we have it. So next one. So we think about one theorem. Summation an, summation bn are convergent. So the series summation of c times an, where c is a constant, summation an plus bn and summation an minus bn. So we have this result. What is like a summation from n equal to 1 to infinity c times an? Only take out c. This is possible. Only take out c. We have c times summation from n equal to 1 to infinity an. So this one is summation from n equal to 1 to infinity an plus bn. So what's that? Only distribute summation. So we have this result. Third one, summation an minus bn, similar. Only distribute summation to first and second one. Summation from n equal to 1 to infinity an minus summation from n equal to 1 to infinity bn. So proof. Summation can, how can you do that? You can change it, limit and partial sum. The limit n is going to infinity, summation from I equal to 1 to n, c times ai. The next is, so we have like a partial sum, you can use the property of partial sum, take out c. So like this, limit c times summation I equal to 1 to n ai. One more, this limit and constant c, take out. The c times limit as n approaches infinity, summation I equal to 1 to n ai. Next, change back. This one is exactly same to summation form. You can change back. So that's it. It's a proof. Second one, similar. Use limit and partial sum. The limit summation I equal to 1 to n ai plus bi. You have to use property of partial sum. You can distribute summation to first and the second one. Limit summation from I equal to 1 to n ai plus summation I equal to 1 to n bi. The next is distribute limit to the first and second one like this. The limit of summation from I equal to 1 to n ai, this is exactly same to, here. The second one, limit of summation I equal to 1 to n bi is same to this one. So that's it. Whole proof, the property. The third one, similar. The similar. You can prove everything. What's the key part? Here. Take out C. Distribute summation. I'm going to give one remark. This is true or false. Summation n equal to 1 to infinity. So an times bn. Is it true? Is it true or false? Distribute summation. What's that? Is it true or false? What do you think? True? It's true? True? No, don't distribute. When do you distribute? Only summation and difference, you have to distribute. Product, no. This is not limit, but total difference. Very similar to the integral. Do you know this one? Integral f times g dx is distribute integral f dx, integral g dx? No, they're similar to the integral. You cannot distribute, impossible. So summation n equal to 1 to infinity, an over bn. The summation an over summation of bn. You can distribute summation to first and the top and the bottom one. No, don't do that. Really be careful. So when do you distribute? Only addition and subtraction. You have to distribute summation. Only this case, right? Product, don't distribute. Quotient, don't distribute. Don't distribute, this kind of things. Here, find the sum of the series. How can you solve? Here, this is summation. You can distribute summation. So one more. So 3 is constant. Take out. We have this form. Is it right? It's good? This is good? The next tip. How can you calculate? These are two things. The first one, what is like the best way? I want to use the whiteboard is better. I can use it like a whiteboard. You can change it, the whiteboard, explain more. So here, so we are going to whiteboard here. Was it like the previous example? Do we have summation? The n equal 1 to infinity. Do we have the take out 3? We have 1 over the n plus 1 times n plus 2 plus summation n equal 1 to infinity 1 over 3 to the power n. You can calculate this one. How can you calculate? The first one. Was it like a summation from n equal to 1 to infinity, 1 over n plus 1, n plus 2. The inside one is exactly, I can write like this. Summation, the n equal 1 to infinity, 1 over the n plus 1 times n plus 2. How can you calculate this one? So like this. This is exactly 1 over the linear function times the linear function. You have to change it to the partial fraction form. Remember this one? So I'm going to use formula 1 over the n plus a times n plus b. Same to what? 1 over b minus a times 1 over n plus a minus 1 over n plus b. You can use it, this one. So here, we know the b is greater than a. You can compare 1 over the n plus 1 times n plus 2. What is a here? This a is 1. The b is 2. You can plug into here. So we have this result. So 1 over the b minus a, 2 minus 1. 1 over n plus a is n plus 1 minus 1 over n plus 2. So 2 minus 1 is just 1. You don't need it. So 1 over n plus 1 minus 1 over n plus 2. So we have it. We can replace. This is same to what? Summation. So n equal 1 to infinity. Just 1 over n plus 1 minus 1 over n plus 2. You can change it like this. So one more. You can change a partial sum. Take limit, n approaches positive infinity, summation I equal to 1 to n. Only replace m by I. Replace m by I. 1 over I plus 1 minus 1 over I plus 2. So like this. Next, you have to expand. Keep limit, n approaches infinity. What's the first one? You plug 1 into I. Here, the first term is 1 over 1 plus 1 is 2. 1 over 1 plus 2 is 3. Plus, you can plug 2, second term. So I equals 2. You plug I equals 2 into I. The 1 over 2 plus 1 is 3. 1 over 4. So keep going. The 1 over 4 minus 1 over 5 and so on. What's like the last term? The last term is plug n into here. The n. So we have 1 over n plus 1. The 1 over n plus 2. Was it like previous one? The previous one is only replace I by n minus 1. 1 over n minus 1 plus I. 1 is 1 over n. The n minus 1 plus 2 is n plus 1. Like this. Next, you have to cancel same things. 1/3 canceled. 1 over 4 canceled. 1 over 5 canceled. All things is canceled. The remaining term is 1 over 2 and minus 1 over n plus 2. So we have, this is limit. N approaches positive infinity. 1 over 2 minus 1 over n plus 2. The n is going to infinity. So this n is going to positive infinity. 1 over infinity plus 2 is going to a 0. So we have this one is going to 0. So what's like a final answer? The final answer is 1 over 2. You can plug this 1 over 2 into here. You can keep 3. We have 3 times 1 over 2 plus the second one. How can you solve second one? Do you know some idea how to solve this one? Summation n equal to 1 to infinity 1 over 3 to the power n. Do you know how can you solve this one? So do you have any idea for solving summation 1 over 3 to the power n? Do you have any idea? How can you solve? Yeah, 1/3 n, you're right. The change to the n equal to 1 to infinity, same to what? Yes, 1 over 3 to the whole power n. Yes, change it like this. You have to expand. Plug 1, 1/3. Plug 2, 1/3 square. Plug 3, 1/3 cube. What's that? This is exactly what? Geometric series. Geometric series. Do you remember geometric series? A plus a times r plus a r squared plus keep going. So like this. We have 2 possible answers. A over 1 minus r. The if the absolute value of common ratio is less than 1. The another result is divergent. The if absolute value of r is greater than or equal to 1. That's right. This is geometric series. You can check. In this case, what is A? What is A here? What is A? Yes, first term. It's the first term, 1/3. What is R? Yes, here, 1/3, 1/3. It's the base of exponential function. 1/3 is R. You can take absolute value. Absolute value of R is absolute value of 1/3 is exactly the same to 1/3. How much less than 1? Yes, we have convergent result. Answer is the A over 1 minus R. What is A? The A is here, 1/3. The R is 1/3. 1 minus 1/3. So we have 1/3 over 2/3. You can add it. The 1/3 times the reciprocal of 2/3 is 3/2. 3 is crossed out. Answer is 1/2. You can plug into here 1/2. What's the answer? 3/2 plus 1/2 is the 4. Right? It's like a whole idea for solving this problem. It's like idea. So we are going back to slides again. Here. So this is my explanation. Here, like this. This one. So next, this is the last one. If the series summation from n equal to large n plus 1 to infinity an is convergent, then the full series summation from n equal to 1 to infinity an is also convergent. Here, proof. What's like a whole series? Full series is you can just split two things. It's right here. Summation from n equal capital N of an, n equal capital N plus 1 to infinity an. You can change it like this. So what happens? This is convergent. Is right? So what does it mean? This is finite. What's like finite sum? Only add finite number. This case is what? A1 plus, A2 plus, keep going, plus just an. Only finite terms. The finite terms add finite terms exactly finite. The finite. The finite plus finite is finite. What does it mean? Series is finite. That's it. Also convergent. That's it. This is a proof. So here, summation from capital N plus 1 to infinity is convergent automatically. The full series is also convergent. Also convergent. This is whole idea. Is right. The one example is summation n equals 10 to infinity an equals 100. You can check if summation from n equals 1 to infinity an converges or diverges. Converges or diverges. What is your answer? What is your answer? What is your answer? Divergent, is right? Divergent? Convergent? Convergent? Yes. Here, 10 to infinity is 100. What does it mean? The partial one. Here, the summation n equal to capital N plus 1 to infinity is convergent. So full series is also convergent by using theorem. Yes, convergent, convergent. I can check what you say. The if it 2 not 4. So I can check my previous example you said. I can check my previous example. Sorry, I can check. Oh, you're right. Sorry. Yes, this is not 4. Sorry about that. 3/2 plus 1/2 is, yes, this is 2. Thank you. Yes, answer is 2. Yeah, thanks. Thanks. The answer is 2. Yeah, you're right. Yes, answer is 2. Thank you. Okay. So this is all for today's lecture. So thank you for attending my class today, very earlier for attending till the 1:30 minute, very long time. I really appreciate that you attended my class. So if you have any trouble, any question, write the question on the chatting board. I answer your question. If you don't have any question, you can leave a live session. Oh, you're welcome. You're welcome. Okay, see you later. You're welcome. Yeah, you're welcome. Yep, you're welcome. I'm waiting. Any trouble, any question, only write your question on the chatting board. If you don't have any question, you can leave a live session. Yep, I can just waiting. Okay.